Yeah, thank you very much for having me here. I've never been to MacDevOps. It was on my bucket list, is no longer on my bucket list. So, hey. I'm Bryson Tyrrell. I'm here to talk about Supercharged CI/CD with GitHub and AWS. And you might ask, what makes it supercharged? Because 60% of the time when you put words like supercharged in your titles, you get accepted every time. All right, so we're going to kick this off a little bit here, and those presenter notes are really small, so I'll do my best here. This should be clocked around 20 minutes, so maybe there's some Q&A, maybe there's time for people to correct me on stuff. We'll see. I don't know if it's 20 minutes because I haven't rehearsed it. I finished it this morning. All right, but CI/CD, what is that? Continuous integration. That is the practice of integrating changes frequently and ensuring that code is in a workable state. Very lofty. Continuous delivery. That is the practice of automatically releasing those changes to production, preferably in an automated fashion. The two of these things together give us the CI/CD pipeline. So the original plan for this talk was I was going to go through CI/CD pipelines that I've built for stuff before and go through my process. And I decided I didn't really want to do that. That would come off as pretty opinionated, and I can't have anyone accuse me of being opinionated on things. So instead, I decided, okay, well, how about we just go through the entire CI/CD process and we talk about the scenarios where you might use GitHub and AWS services together in order to achieve a CI/CD pipeline. All right. So before we get into any of that, we're going to cover a couple of topics that are very core to this. First one is going to be interoperability between AWS and GitHub, because it's important to understand how we can securely have both of these things talking to each other. And some of the ways that we might go about doing that might impact, how we design our pipelines. All right. So in reality, depending upon what you're doing, each phase of your overall CI/CD pipeline could just be purely achieved with one or the other, and you won't actually have to mix the two of them together, Let's see. Your choices, they will affect a lot of things. Security is always the big one up front. Like your security profile for your pipeline is going to be very dependent upon the choices of what services you use at what stage and how data is crossing the wire between them. Complexity is another one of those trade-offs, as well as just the cost in some cases. Like, where are you spending money, and who's actually paying the bills, and are you allowed to have extra spend for some of those things? For the rest of this talk, we're just going to assume that we're all pretty much using GitHub for the most part. It's not GitLab and AWS. I'm sorry, Joel, but I'll just show of hands here. How many of you are using GitHub for your code bases? All right, a little skewed. How many of you are AWS customers? Excellent, thank you. All right, so the really nice thing that's going on here, and this happened several years ago, and my teams back when I was at Jamf abused this extensively. With GitHub and AWS, you can actually establish GitHub as an OIDC provider in your AWS accounts. And then through this connection, you can allow GitHub to assume roles which will grant it permissions into your AWS accounts in a manner that doesn't have any long-lived credentials. Very great. We're going to see a lot more about how this helps us later on. All right. And I'm just going to give a really quick explanation about what that process actually looks like, because I just said a whole bunch of word vomit that not everybody here has probably played with yet. So anything that we do with GitHub Actions, which we'll get into GitHub Actions in a second here, that needs to talk to anything in AWS, it needs access credentials to do so, like with all things on the web. So the very first thing you're going to do is you're going to go into the IAM console, and you're going to establish trust with GitHub, saying GitHub is allowed to actually assume roles in my account. I'm establishing this trust. There's instructions for it online. We're not going to be getting into the process here because I have limited time. But once you do that, you can now create IAM roles in your account, and in the trust policy for those roles, you can say GitHub is allowed to assume this role. Specifically, GitHub Actions, when they are triggered off of my repository, off of a condition of the branch name and the there's actually several conditions in there that you can set. I don't remember all of them off the top of my head, but you can be very fine-grained about the scenarios in which GitHub is allowed to assume that role and get temporary AWS credentials. So once you do that, whenever you have a workflow that fires off for GitHub Actions, where you are doing that, it will then call STS assume role with web identity. It's a fancy API, but really all it's doing is GitHub has signed a token, handed it to your workflow saying, here's your token with all the claims in there that identify this repository. GitHub Actions can now send that off to STS. And then if all the conditions are met on the other side for the role that you're trying to assume, STS is going to return temporary IAM credentials, not long-lived ones, just temporary ones. And now for the lifetime of that workflow, you can use those credentials to call AWS services. Nice. So the nice thing about this is if you're using a lot of the AWS provided GitHub Actions, and we'll talk a little bit more about that in a second, these things just work with the SDKs and the CLIs that are available to you. There, I said we were going to be getting into this. So GitHub Actions. This is a service that allows you to find workflows that run in response to events that are happening within your repository. These are all YAML files that are stored inside a .github/workflows directory inside your repository, so they're a part of your code base. And by default, GitHub Actions will execute on compute that GitHub owns and runs, probably in Azure. But the reality is, you can actually configure GitHub Actions to use compute elsewhere as well. Again, time limited, we're not going to get into that, but it's kind of important to know that just because you're using GitHub Actions doesn't mean you have to pay GitHub for their compute. So how does this work? Well, so as a part of your workflow, you have to define what events trigger this workflow. And then on that event, you will have in that YAML file a series of jobs defined, and they can either run in serial or they can run in parallel. It's up to you to decide. But all these jobs are going to start executing, and then they are going to start executing different steps inside there. Now, these steps can be any number of things. They could be a command. They could just be commands that are running, so little one-liner scripts or multi-line scripts. They can be Docker images that you actually fire up and pass the parameters into. They can also be predefined GitHub Actions that official providers like GitHub and AWS and others have already defined, and you can just state which one you want to use. They can also be community provided. It's a lot like auto package recipes. There's just millions of actions out there waiting for you to discover. There really is an incredible amount of customization that you can do inside GitHub Actions. I won't be getting into how to define them at all because, again, time constrained. But it's a really, really powerful automation tool once you start to get into it. And there's a lot that you can do. So on the AWS side, a lot of the same things that you do with GitHub Actions you can do in here. It's just that they are sort of split up across multiple services that are intended for developers. The first one I'm going to actually bring up is code commit. AWS does actually have its own code repository service. And even though it doesn't have the same user experience as GitHub, it is already inside AWS and it's tightly integrated with the services there, so there are use cases for it. Code build. Code build is a build system that AWS provides. And it's very similar to GitHub in that, or it's very similar to GitHub Actions in that you define what code build is going to do in a YAML file called a build spec that you include inside the repository. And that build spec file is broken out into multiple phases. You have a installation phase to prep the build environment. You have a pre-build phase, a build phase, and then a post-build phase. And then you ship off the artifacts from that somewhere else. The last thing I'm going to bring up, because there's a whole bunch of services that AWS does offer all this stuff, but these are the ones that I'm kind of focusing on for this CI/CD talk, because these are sort of the bread and butter. Code Pipeline is an orchestration tool. So, lost my, there we go. So with Code Pipeline, it's defined in stages, and each one of these stages might contain one or more actions. It sort of fits, again, that GitHub Actions model. Pipeline always starts with one or more sources, and then those sources can automatically trigger that pipeline to run through every single stage and execute all the actions within those stages. Okay. So now let's actually talk about the CI/CD pipeline itself and start applying some of all these services that I just talked about to, real-world uses. The fundamental components of our CI/CD pipeline, and this is mostly documented the same way depending on what you're looking at online for information about like what is CI/CD. You're always going to have a source that's going to be, in general, code in a repository somewhere. Then you're going to have a build phase, a testing phase, and a deploy phase. And to really be truly a continuous integration and continuous delivery pipeline, all of these things should be automated. So like your source changes should be automatically promoted to your builds, which should automatically be promoted to testing, which then should automatically be promoted and deployed if all of that passes and you get to the very end. You don't want to have manual intervention in this process where possible. All right, so let's go into talking about source a little bit. So there are a lot of strategies out there for how you do source control and how you manage a code repository or a project. Generally for me, I always treat the main branch as my production branch. Like the state of the main branch is the state of production. That's how I generally go about doing it. So I've got a commit on the left. I made another commit. This is my timeline for my Git repository here. When I want to make changes to that, I will go off into a feature branch. So I'll branch off main, call it whatever, Bryson's new feature, do a bunch of work, and then when it's time and I'm ready, I will then merge those changes back into main and keep going forward. So when I'm working within feature branches, it's really up to me to make sure that my code is like, passing tests and everything. Like I can run unit tests, I can run linting locally. Like there are also ways as maintainers for us to enforce those things. If it's a group project, you can have pre-commit hooks, so that way like it won't let you commit code unless all these checks are passing. Like those are all pretty good. But there's certain amounts of like testing and validation that can't happen at that level local on the machine. So there's actually a second point in the process where I think it's really important for you to consider in your CI/CD pipeline of putting in guardrails and ensuring code that doesn't pass, that first layer of validation never gets merged to main, because in my world at least, main is production. So everything should be passing tests before it's allowed to be merged back. All right. So we all use GitHub. Git repositories, that is the, claim to fame for GitHub. It is what it does best. It kind of is the gold standard, and as we saw, everyone here is already using it. While we probably aren't using code commit, again, there are places to maybe take advantage of it depending upon your environment and depending upon the controls you need to have, because code commit's already inside the AWS security perimeter. It's in the account. So we're going to walk through pipeline scenarios for the remainder of this presentation. First scenario here for the source phase, well, that's pretty self-explanatory. Like for this pipeline, that's it. We have a GitHub repository. That's where it is. Done. For this second possibility here, let's say that what we want is as soon as code is merged into GitHub, we want to then handle everything in AWS from that point forward. Well, from there, we could actually leverage a GitHub action to mirror that code into code commit. So again, there has to be a credentials exchange here. This GitHub action is going to sync two separate Git repositories. In order to do that, it's going to have to call AWS, assume a role that has permissions to that code commit repository, and then perform those operations. But, like for this pipeline, that's actually going to be the extent of it. Like those are the only permissions that are exposed to GitHub at this point. The ability for this repo to sync specifically to this repo, and that's it. AWS credentials exchange doesn't happen anymore. All right. The builds, whoops, go back. Knew that was going to happen. All right. So in the build phase, this depends on what you're doing. A lot can happen here, and it all comes down to what's in your code repository. If you're working with code that needs compiling like Swift, you have to do that in order to actually build something that's going to be testable. You can't just test the raw Swift code. I was just waiting to see if Mike was going to eyeball me for getting that wrong, but we're good. With Python, there's nothing to compile. Like the code is the code and it gets plugged into the interpreter, so there's no build there. So build might not apply to Python projects necessarily as it would to a compiled language like Swift. You might be transpiling things. So like take Pickle, for example. Who is using Pickle? Maybe. It's kind of cool, really. Like, it is a declarative language for configuration that can then export into multiple different formats, like YAML. Well, you're not going to deploy Pickle files into production. That you're going to translate it over into one of those formats first. So your build phase, actually, if it's a repository full of Pickle files, is going to be making them into something usable. That sounded like a dig, but it wasn't. The other thing is just that these files, like what if it's just JSON and YAML files in your repository? Well, they probably conform to a schema, so you might need to apply something there. Like, again, build phase, little flexible depending upon what you're doing in here. The point of the build phase is that at the end of it, we are going to have an artifact that we can then pass along to the next step. All right. So, on commit to the main branch, in our first pipeline here, we can then trigger a GitHub action that's going to perform the build, and then maybe, just for the sake of this example here, it'll take that built artifact and it'll store it inside the repository's releases. I think you can stage releases without actually like publishing them. So like, that's a good place. This is releases are kind of where you can store files that are an output from your repository code. That's kind of the mechanism that GitHub has available to us. But that might be the first step here. Like we have a commit, we have a push onto the main branch, and then we're going to store the result of the build that's processed by GitHub Actions into the release. And this, again, is going to be a workflow file that is listening for pushes on the main branch and then running actions. And with GitHub, permissions to itself, like having permissions back to the repository when the GitHub action is running, or things around that repository, is a pretty simple story when it comes to access controls. In our mirror pipeline, it's going to look a little bit different. So we have the mirror happen, and that push to the replica. Now, code pipeline is an orchestration tool. And in this case, code pipeline, the source for that pipeline is code commit. So when that push happened, we can now have code pipeline automatically trigger because it's watching that repository. And then it will then take that, copy that repository, hand it over to Git code build. Code build will do whatever you had defined in the build spec for like that build sequence, and then it can store the resulting artifact in an S3 bucket. But there is another option here, which is this third example pipeline that I've now snuck in here, where maybe we still want all the builds to happen through GitHub Actions, but then we're going to hand the artifacts over to AWS from that point. So, and we'll get into why you might want to do something like this later, but in this case, it's pretty much identical to the first pipeline, except you're going to have the action assume a role in GitHub to give it put object permissions to S3, and then wherever the output directory of your build is, you're going to then just AWS S3 copy those files right up there. Or there's also an AWS action for GitHub Actions to do those very things. But here, all your pipelines have processed their build phase, and they've now stored an artifact somewhere as a result of that build. So, testing. Everybody here tests their code, right? Yes, good. Always. So, there's a Tom Bridge quote coming up here. So, we have an artifact from our build, and now it has to be validated. Like, yay, the build passed. That doesn't mean anything. We have an artifact. We need to validate that artifact before we proceed any further. We have to ensure it's in a working state. This is the second half of our continuous integration piece. So we've performed the build, but now we need to validate the build. And once again, what happens here is going to vary a lot depending upon what your artifact is. For code, we're going to have unit tests. We'll also have integration tests. depending upon, how you personally look at those things. For configuration files, there's going to be linting. There's going to be schema validation. You could also have linting on your code for that matter too. Whatever happens here, the outcome of this phase is that we have a validated, verified artifact that is production ready. That is the key. So some of you might have been wondering here, like, where do tests fit into this since we've already done the build? Well, as it turns out, this is where things start to like blend together. In most cases, we can kind of combine our initial build and test phases together. Like you already have something running, you have to produce an artifact in the first place in order to run any of your tests for the most part, or you might be dealing with non-compiled code that doesn't need to do that. You could just run the tests right away. The reality is that you can just do this all in one step because then you have an artifact that is verified and now it's gone out and it's ready for the next piece of your pipeline. And something very important to call out about these two right here, because we're using GitHub Actions to actually perform the build and perform the test immediately after the build is performed. GitHub Actions can be tied to pull request events. And when you do that, they become checks. And you can enforce that all checks have to pass on a pull request before merging is allowed, which means if somebody opens a pull request, you don't have to do the eventing as push onto main. You can do event on pull request to main. And then only for pull requests to the main branch will it perform the build, run all the tests, and if either of those things fail, it blocks the pull request automatically. And if you're doing your rules correctly, there's no overriding that. So in addition to, at this phase, manual intervention is okay because we're at the start of it. In addition to approvals by reviewers, you can also require builds and tests are passing from GitHub Actions, and they have to fix those things before it can proceed, even with approvals on the repo. All right. So the build tests are validated. The build test phase that we've got going here is validate the artifact, but in a lot of cases, we might need to still take that output and perform some more rigorous pre-production tests without any kind of mocking. So, I mean, again, depending upon how you look at them, unit tests are very low-level functional code tests. You should be able to run those on your own computer as you're working on the code. They should pass. Integration tests are going to be more all-encompassing, higher-level interfaces, testing a broader range of it, trying not to mock anything. But sometimes your integration tests do need to involve external services. Sometimes you have to do end-to-end testing. The implementation of this is going to look different for everyone depending upon what you're doing. But in the event that you need to, there could actually be a secondary testing phase here. So in GitHub's case, another event that you can listen for is when something happens with a release. And there's a whole bunch of options for that. But like if a release gets staged, for example, you can event on that and then use GitHub Actions to run another set of tests that are a lot more involved than the tests that went for the build, because maybe these ones are more expensive because they have to call out external APIs or something. Our second pipeline here, we're already in the perimeter and now of the AWS account. And now, because, again, code pipeline can have multiple sources, S3 can be a source for code pipeline. Multiple types of AWS services can act as triggers for this. In this case, the act of putting a file into the S3 bucket is the trigger for this code pipeline, and it's going to call code build and it's going to do that, more rigorous testing. We already did our unit testing and everything up here so that we know the code that went into the main branch is valid as far as our unit integration tests are concerned. We can now kick off this pipeline and do more rigorous testing inside an AWS account. And down here, this is kind of the same thing with a little bit of a difference. It's just that we're already inside the context of code pipeline. So this is not actually S3 triggering it. Code pipeline itself has said, okay, I passed my build and test phase. Now my next stage is going to be running these heavier duty tests. So, I'm coming up on time here. So our CI/CD pipelines have now reached the point where we have verified, validated artifacts that can be deployed. And this is yet another thing that's going to look wildly different depending upon what you're doing and where things are going. So, show of hands, who here uses Terraform to deploy things? Yep, not surprised. How many of you deploy with scripts? There's no shame here. Sometimes the best tool for the job is the hammer. And of course, in the context of we're inside AWS and when we're executing through code pipeline, code build, if you need to do things like Terraform and scripts, you would probably run code build because you have a build spec that actually calls those commands. It actually makes for a great like script runner in these cases. Otherwise, who here works with CloudFormation? If you say CDK, I'll accept that as an answer as well. But like if you are working with CloudFormation and you have files in your repository that go out there, that's a native call from code pipeline. It doesn't need an intermediary. You can just progress to the next step, tell it where those template artifacts are, and it'll just do the work. All right. So in our first one here, if GitHub Actions is handling everything, this is where the security story gets a little bit murky because it's been pretty nice up until this point. But now you are likely deploying into a cloud provider like AWS, and you're going to have to allow GitHub Actions the ability to assume a very broad encompassing role that grants create, read, update, and delete permissions to whatever resources there are that you're trying to do. Like if you're using Terraform for AWS, it's not that different from CloudFormation. You still have to grant resource permissions for everything that you're managing. So a near superadmin IAM role has to be assumable by GitHub Actions in this case. And depending upon where you work, that might be kind of hard to sell. So the same thing is really true with our next two pipelines, but the difference here again is that we're already inside the AWS account, and inter-account IAM permissions are a much different story, or even permissions between AWS accounts within the same organization. So in this case though, maybe it's going to CloudFormation. If it's code build, you're probably running a script or you're using the Terraform CLI, any of those things really. But those options are already integrated into code pipeline, and code pipeline has access to pass the role needed to actually do all those things. And it's the same exact story down here because again, the deployment is just another stage of the pipeline. It just comes down to what are you doing and how do you need to achieve that when you get to the deploy phase. All right, so these examples that I covered here today were very high level. They were simplified views of CI/CD pipelines with these. And while some of the phases were consolidated or split across multiple points, it's kind of important to identify that they were all present. They were all present. We went from source to build, test, and finally deployment. And all three of those demonstrated ways to automatically progress that through. So absent my presentation today was a whole bunch of code. And by code, I mean screens and screens and screens of YAML. But, again, what I said about putting the word supercharged into, titles, I went ahead and pitched this exact same presentation for next month. So if you want to see an additional 40 minutes of YAML and a technical deep dive on those three example pipelines, you can come check this one out.